Hey friends, welcome to episode 1 of the interview prep series. Today we're going to be starting on our system design lessons. So if you're new here and you haven't seen my previous video, go ahead and check it out. To sum it up, my goals for this year was to 1, get over my interview anxiety, and 2, just become a better engineer by deep diving into certain topics that I might not have exposure to on a day-to-day basis. And what better way to do that than learning together? So here we are. So before I get started into the actual lesson for today, let me just break down what I'm doing in this series and why it's structured this way. So a lot of system design videos you see on YouTube, there's already thousands of them that go over the same problems. How to design Twitter, how to design Reddit, how to design a URL shortener. We already know all these questions. And mind you, I can probably recite the answers to all these questions by heart at this point through simply the amount of times that I've watched these videos, but it's important to have a more in-depth understanding of why we make certain design decisions. So this series is gonna be broken down chapter by chapter, kind of in the same way that you'd approach a system design problem. So it's kind of in a logical order. Now, a lot of the content in this series is gonna be gotten from this special book right here. I'm pretty sure every engineer has heard of it. If you haven't, it's called Designing Data-Intensive Applications by Mark Kleppman. This is probably one of the first books that was recommended to me when I was a junior engineer, and I just didn't read it, okay? It was long, and I didn't read it until last year. As you can see, it's earned its battle scars, and that's what we're gonna be using for the basis of a lot of our discussions here. But with that being said, let's actually get into the lesson for today. Okay, so today we're gonna be doing capacity estimation for dummies, okay? No offense. We're gonna be starting from the beginning, assuming you don't really know much. So for those who don't know already, capacity estimation is the process of estimating how much computing resources that our service is gonna need to run. Now, if you don't know what I mean by resources, that's fine. You can kind of think of it in terms of the specs of your laptop, right? When you go into the Apple Store and buy a laptop, it'll give you different specs. For example, the number of CPU cores, the amount of memory, the amount of disk space, I don't know, and maybe GPUs. I don't know. I'm not a gamer. I don't know. So they do like stuff like that. Maybe I have GPUs. I don't know. Okay. And the more of these resources you have associated with the laptop, the more expensive it is. So when it comes to capacity estimation, this kind of goes along with why it's important. This ensures that we have enough resources to handle peak load efficiently and make sure all of our users' requests are served in a timely manner. And we don't want to over-provision resources because that's going to be very expensive. So there are a few reasons why we need capacity estimation. One is to determine the number of servers you need. Mind you, in a system design interview, servers come in different specs, so you're probably not going to get asked to know how many exact servers you need, but that's the overarching principle of it. 2, we're going to need it to identify system bottlenecks. Bottlenecks are when a certain resource constrains the amount of requests that we're able to process. So as I said, thinking about it in terms of your laptop, let me just talk a little bit about what these resources are if you're not familiar already. So first we have CPU, and that's going to be the processing power that's required to actually serve requests and do computations. So next we have RAM, and that's going to be the resources needed to store data temporarily for our application. Next we have disk, and this is the resource that we need for persistent storage. So think of an actual database. And finally we have bandwidth, and this is the network capacity, so it defines how fast and how much data we can send between client and server. So when you start off a system design question, you're going to ask the interviewer for a few key details that you're going to use to calculate these requirements. How many total users does the system have? 2, you're going to want to know how many daily active users a system has. 3, you're going to ask what is the average reads and writes per user over a certain time period. And 4, you're going to either ask for the data size that's going to be used in these reads and writes, or you're going to estimate it yourself. So now that you know what to ask, let's actually understand how to do these calculations. Before you do this question, you're going to actually want to have a few key numbers on hand. You're going to want to have memorized the metric prefixes and their corresponding powers of 10. And you're also going to want to have a few key numbers known off the top of your head to help do the problem more efficiently. Obviously, you probably know how many days are in a year, 365, but you're also going to want to know off the top of your head how many seconds are in a day, which is 86,000. Now, to make math a lot easier, you can round these numbers. So when I do system design questions, I round the 365 to 400, and I round the number of seconds in a day, 86,000 to 100,000. So now you're mostly dealing with a lot of zeros. All right, so here's the question we have. You are designing a URL shortening service like Bitly. Estimate the resources required to support the service. Assuming we have 500 million total users, 1% of those users are daily active users. Each active user creates 5 new URLs per day. Each URL is accessed 20 times per day on average. Each URL is stored indefinitely. The system should be able to handle 5 years worth of data, and assume each URL entry takes 500 bytes in storage. So the first question we have is how many new short URLs are created per day? So the question gives us that we have 500 million total users, 1% of those users are daily active users, and each active user creates 5 new short URLs per day. So let's do the math. We have 500 times 10 to the 6 total users. 1% of those users are daily active users. So 1 times 10 to the negative 2 are active users, times each user creates 5 short URLs per day. So we have 500 times 10 to the 4th times 5, which is equal to 2,500 times 10 to the 4th, which is equal to 25 times 10 to the 6th. New URLs created per day. All right, so next we have how many total URL accesses or reads happen per day. So we know that we have 25 million short URLs created per day based on our last question. So we have 25 times 10 to the 6. And we know that each short URL is accessed 20 times per day on average. So we multiply that by 20 based on our requirements. So we do the math. We have 500 times 10 to the 6, or 500 million total accesses per day. Okay, so the next question is how much storage is required per year and over 5 years. So we know that we create 25 million URLs per day. So that's 25 times 10 to the 6 times 365 days a year, but I'm going to round that to 400 for easier math. And each of these URLs are 500 bytes. So here we have 125 times 10 to the 8th times 400. And doing some more mental math, we have 500 times 10 to the 10th, which is going to give us 5,000 gigabytes, because 1 gigabyte is 10 to the 9th. Okay, so now that we have the amount of storage required per year, we can multiply this by 5 to find how much storage we need for 5 years. So 5,000 times 10 to the 9th, which is gigabytes, times 5, which we have 25,000 times 10 to the 9th, which is going to be equal to 25 terabytes. So it's easier to do the throughput first, and then we can calculate the bandwidth for uploads and downloads after the reads and writes per second. Now we need to divide this total number of URLs accessed per day by the number of seconds per day. So we have 25 times 10 to the 6 times 20 accesses per day, and this is going to be divided by the total number of seconds per day, which is 86,000 or 100,000 for easier math. So here we have 50 times 10 to the 7th divided by 100, or 1 times 10 to the 5th, which it is going to be equal to 50 times 10 to the 2nd, which is equal to 5,000 reads per second. So we already know that we have 25 million new URLs created per day. So let's just take this number and divide it by the total number of seconds per day. So we have 25 times 10 to the 6 divided by 100,000, or 100 times 10 to the 3rd. And this will give us 25 times 10 to the 6 divided by 1 times 10 to the 5th. Doing that math, we have 25 times 10, or 250 writes per second. All right, so now that we know the reads and writes per second, let's do the bandwidth calculations. So now our bandwidth calculation is just a function of our reads and write per second rate times the amount of data we're actually transmitting. So we know that each URL is 500 bytes, but we also know that when we do send a request, we probably have to estimate that other data is going to be part of the request. So I'm just going to add an extra 1,000 bytes for any other request information, like the request headers or any other data. Now for our reads per second or download bandwidth, we need 5,000 reads per second times 1,500 bytes, which is going to equal 75 times 10 to the 5th bytes. Or we know that 1 byte is 8 bits, and bandwidth is calculated in bits per second. So we have 75 times 8 times 10 to the 5th bits per second. And this is going to be equal 600 times 10 to the 5th bits per second. Or we can also write this as 60 megabits per second. All right, so now that we know our reads, we can do our writes or our upload bandwidth. So we have 250 times 1,500 times 8 bits per byte. And that gives us 30 times 10 to the 5th, or 3 megabits per second for our upload bandwidth. Okay, so now for our final question, what bottlenecks might arise? We see that we have 5,000 reads per second and 250 writes per second. So that will give us about a 20-to-1 read to write ratio. So our reads are significantly higher than our writes. So we know that when we do our actual design, we need to optimize for this. So now, what are these calculations for, right? Well, as I said, these calculations are going to help inform certain design decisions. And we're going to get into that more in later videos, but I want you guys to keep these at the top of your head. These calculations are going to help us choose the right database, help us choose a data partitioning and replication strategy, come up with different performance optimization techniques, also give us a better idea of how we want to scale our system. But I'm going to keep this video short. That's all for today. So don't worry if all this sounds new, we're going to go over that in the next videos. In the meantime, do a few practice problems. I'll link them down below, as well as the notes for this video. If you liked this video and it was helpful, please be sure to like and comment, and also subscribe so you can see the rest of the videos in the series. But I'll see you later.